Good morning. Welcome to week 2 of our 8-week bi-term format. And because it's an 8-week format, there's a lot of compression of the topics when you double things up. And the weekly folders, the content folders, they may seem slightly schizophrenic, multiple personality disorder, because it'll say, like week 2, we're going to do healthcare this week, like it does this week. And then you sneak in this manufacturing thing and what? We're talking about manufacturing healthcare, no, it's because this is a compressed 8-week schedule. And the course designers basically just put week 1 and 2 of the 16-week semester into week 1 and so on. And that's what we have. So I'm here for clarification and edification and illumination. And if you have any questions, or if there's anything confusing, I don't I'm not a huge fan of the way all the instructions are written. So if anything is confusing, please email me. I've only gotten a couple of emails, so I think I respond pretty quickly. Um, so yeah, anything seems unclear, please shoot me an email. Okay, so this week we will. I'm gonna go like I said. I'm gonna cover every objective. Just talk about it, if nothing else, um, from the content folder that is more detailed than the syllabus. And I need to back up, talk about big data and the uh, the role of the data scientist within the much larger analytical universe. Um, and then we have 2 assignments this week. We've got a discussion board and a research paper, and that's the way it's going to be rolling for the next few weeks. Uh, Discussion board and a paper. And then I also wanted to be sure and point out dissertation resources, dissertation preparation materials in the content folder, um, because there's you cannot start too early. And guys, let me say this: if you're new to the program, or even if you've been in it a little while, this is not another master's degree. I saw in a lot of your introductions that you were hoping to learn a lot about big data and data science. And um, I, with the University of Cumberland's, as it was with my own program with Colorado Technical University, the courses are not so much about learning and memorizing uh, topics. It's it's the focus is really learning just enough about it so that you understand what the term is, what the thing is, but then you you are a researcher. That's what a PhD is. It's not just good enough to be a subject matter expert. What the course is for is to teach you to think like a researcher and to become a researcher that can contribute to the body of knowledge. And that, I think, when the first time I heard that in my own doctoral program, I was like, what? Because I don't know that I knew that going in, that it was so focused on research and research methodologies and how to frame a research project such that it fills a gap in the literature, that you're doing something in a new way or covering a new topic, kind of thing. So anyway, dissertation, that's the big challenge. These discussion boards and, you know, even the papers are not all that challenging, really, to me. The 120-page dissertation was a challenge. So there you go. So that's what we're going to talk about this week. So in your course folder for week 2, you will see these objectives. So we want to describe electronic health care, which is all lowercase and not very clear, but I'm going to clarify it. And then how big data is used in healthcare, trends in big data in healthcare, and then whoop, switch topic, how big data is used in manufacturing, and then how the Internet of Things uses big data technology. Well, the Internet of Things doesn't use big data. People use big data anyway. Like I said, I'm just sometimes these are a little confusing, and I really do expect more questions, but I don't get them. So yeah, electronic healthcare. I'm gonna assume that's electronic healthcare records, EHR, electronic health records, which is a a data source, definitely one of the top 8 or so data sources in all of healthcare and healthcare analytics. And the difference between EMR, and I am not that kind of doctor. I've never even worked in healthcare. Um, but in the speaker notes down here, I found a fairly understandable difference between electronic medical records and electronic health records. Electronic medical records are just scanned copies of your paper chart. Can't really be used all that easily as a data source. Um, can't can't really be treated as fields in a database the way that a well constructed electronic health record EHR can. Um, and an EHR can contain a bunch of stuff on you. It can contain your health history, questionnaire data. How are you feeling? Have you ever hurt yourself? Lab data, going back to as far as uh, as it's been plugged into the database. Your whole life eventually will be in there. Um, Immunizations, all the shots, childhood shots we got, measles, mumps, rubella, polio, smallpox, all of that stuff now, COVID, all of that goes into your EHR. Any diagnostic imagery, in addition to like blood tests and other kinds of uh, samples that they can take from us. All that, that an MRI, a CT scan, those things are all X-ray even, are digital now and can be used as data in a like a artificial intelligence image recognition, go through of uh, your your EHR. I gotta wonder someday they're gonna just lay you down on a machine like an MRI machine and just do a whole body scan and find everything. It seems like we're being, as we say, nickeled and dimed to death, um, by the healthcare industry. Because if you had a full body scan and then used software to literally look at absolutely everything in your body, looking for tumors, looking for blockages, abnormalities, poor blood flow, that you could go ahead and just diagnose everything in one go. You just get that done, once a year, whatever, be done with it. Seems like it would save a lot of lives, but they do these little individual things now. And I don't know how good the software is at. They still have a human being looking at all this stuff. So anyway, yeah, how big data is used in healthcare. That's how. And then so you've got, to me, you've got two. areas of research out there in the literature when you go to Google Scholar. It seems like there's just two primary overarching domains of healthcare research as far as the data, the data that's being used. To me, it looks like things are broken up into big data that supports um, community health decisions, like factors that lead to cancer or uh, um, stress leading to heart disease in certain demographics. Community data about all of us that talks about the likelihood or the risk of getting a certain disease and what the damage of that disease is, the cost from a community standpoint. But then there's the healthcare analytics at the individual person level, and that's where you get into some really cool applications like expert systems or decision support systems that can look through your data as much as is available about you, and to include a qualitative assessment of your symptoms that you put in there. Maybe the healthcare practitioner helps you put the description of your symptoms into clinical terms, but yeah, you get all that in there, and then test results, and your demographics, and your age, your lifestyle history, whether you're a smoker or a drinker, those sort of things, and then they can start to diagnose issues with you, either immediate chronic conditions or long term um, health concerns, and then you've got throw in genetic testing. Just yeah, there's just an incredible explosion in healthcare data and healthcare analytics. I know a couple of you are in that domain, so good for you. Fascinating. I think we're saving a lot of lives, though we are spending a lot of money on healthcare. Um, so yeah, and then I've got there's a couple of articles out there. Like I said, none of these lectures are going to be something you can just memorize and regurgitate. We're just way beyond that in the education process. So if that's not what you were expecting, I do apologize, but that is the nature of the beast. So a lot of what you will learn in your PhD journey, I would say the lion's share. I know it was for me. I learned because I was reading all the time, uh, reading journal articles and other sources on the internet. The lecture kind of just sets the tone, sets the stage, sets the topic, but then you are responsible for your learning. Which I know some folks think I'm going to watch the lecture, I'm going to spend 20 minutes on the discussion, and I'm going to get my A, and it's just not that's not happening. So yeah, let me know. Email me if you got questions on that. So how big data is used in manufacturing? So now, if you're a small cottage industry, like based out of a house or a small shop, and you're basically making something that you make as many as you can, and some wholesaler or distributor comes by and scoops them up and you sell them, and then you make some more of those things. You don't need any data support in that kind of manufacturing. But um, you know, going back to the Industrial Revolution, we started using data. Now it was paper based, of course, and slide rules and all that kind of stuff at first. But anymore now, there's all huge amount of data being used in manufacturing, and that's even if it's small scale. You still have uh, supply chain management issues. You've got even a small manufacturer is likely using um, computer aided design, CAD files, and a CNC machine, or a laser engraver, those sort of things, and is using um, e-commerce sites to put sales out there. So you've got sales data, customer data, supply chain data. As you scale that up, think about like a company like Airbus or Boeing or Tesla, that are SpaceX, that are manufacturing things that are hugely critical, safety, that have uh, thousands to millions of parts, components that have to be tracked. Because if anything goes wrong, they're going to want to know the source of the manufacturer of the part that went into the product. They're going to want to know how it was used, how many were used, where they were used. So you have to document all this stuff. So you have this enormous supply chain and utilization challenge. And then inside of the manufacturing process, you've got uh, um, it's a manufacturing 4.0, industry 4.0. Is I included a pretty good article on that in the research paper section. Anyway, yeah, the application of data to manufacturing is fantastic. I have some visibility into a local manufacturer that is a little bit slow to adopt. It's kind of like the story of one of those companies that grew up um, young, 20, 30 or 20s people in the 20s and 30s built this in the 80s and 90s. And now virtually everyone in the company is about to retire, and they've done things manually, just by talking to each other, sort of thing. A corporate knowledge stored in their brains versus actually using data to design, manufacture, improve, their manufactured goods. So yeah, not everybody's doing it, and they'll pay the price. And then this last thing, how IoT uses big data technology. The IoT devices, whether it's your Ring camera or your Fitbit or traffic camera, or you know uh, all of these sensors in the road. There's just IoT is huge and growing. There are so many different devices, body cams on police officers, and the smartphones, tablets, your car, everything is an internet connected device now. These Internet of Things. So they're responsible, kind of, to me, partially responsible for the big data explosion. So that's what I wanted to go back and cover and make sure everybody's on the same page, was regarding what is this big data stuff and what's a data scientist. So it started out, God, I should have looked it back up again. Started out in like 2008. Somebody talked about big data as opposed to just data, you know. And so big data basically has three characteristics, and there is no clear, bright line between data and large and diverse data sets and big data. There's no bright line. Uh, it seems like now it's a buzzword now that I'm a big data engineer. I'm not just a database developer. I'm a big database developer. So you see that, and then there are people that are working on gargantuan, petabyte size databases that change every day and have 14 different types of things in there, and Yeah, that's big data. But just remember, there's no clear line between them. But there's the initial description was a mnemonic of three V's: volume, variety, and velocity, that kind of described the departure, or the ascent of the notion of big data. So volume, yeah, you've got the number of generators and the number of enterprises and people and whatnot and organizations using them, is uh, so just the sheer amount of bits flooding into the ether. Some of it's stored, some of it's not. But yeah, so that's what the volume is. Variety is the formats and like the type of generator. So you've got good old log files coming out of a firewall. So you got text-based data that's formatted. um, then you've got audio files for every phone call ever made, every song ever played, all the YouTube videos. So you've got raw audio data. You've got cameras everywhere. There are millions to billions of cameras taking pictures of things every day. Not just your smartphone, not just the security camera on your house, or even the vest camera from the police officer, but you've got cameras in outer space. There's a really great PBS Nova segment called Rise of the Drones. And this is some number of years ago. It talks about a drone uh, called Argus that used inexpensive but very high quality cell phone cameras, an array of them. Of I don't remember. Seemed like it was uh, 1,000 or so, and each one of them is taking whatever 20 megapixel video in 4K ultra whatever resolution, and then it's beaming that back to Earth. I can't remember how many petabytes a day, or was it? Yeah, it was crazy. The amount, or the different types of data and generators out there. Then you've got social media platforms. Every subscribe, like, dislike, your comments. Good grief, Google comments and plowing, mining through that data. You've got sentiment analysis from millions upon millions of people discussing issues on Facebook to plow through. So just the format of these things, and when you pull data off of a platform like Twitter or um, or Facebook, it's usually coming down as a JSON file or maybe XML. So you've got key value paired data, but you've got traditional databases, traditional ERP systems. Every time you swipe that credit card, that goes into a fairly uh, formatted database. So you've got the variety of data types um, coming at an enterprise or available for analysis is incredible. And the velocities, that's the rate of change and the rate that the data is coming at the enterprise. If you're a Walmart, think about Walmart on a Saturday afternoon. The velocity of data coming into that enterprise, as people are price checking out in the store and doing self checkout and hitting the Walmart app while they're in the store. Just you're just being hit with an incredible the speed of change of the update of the data, as opposed to volume. Velocity is really more about how quickly the data is coming and how quickly you have to react to it, than it is just the storage size, like volume. So there you go. Well, I guess I could have used these 3 slides, but I forgot I had them. So here we go. Uh, um, so yeah, storage, maybe isn't the issue it used to be, as long as Google and Microsoft and folks like that, AWS, keep building bigger and bigger data centers. But then again, that's a carbon footprint and whatnot. Yeah, variety. So many different structured and unstructured varieties of data. And again, it's coming at you um, in real time. And you have to catch it, store it, process it, analyze it, act on it, operationalize it, um, all in virtually immediately. It's not like you can look at last quarter's Twitter feeds and and make a business decision based on that. You got to react in real time. And then whenever somebody comes up with something cool like the 3 Vs and it starts to get tossed around, somebody will add to it. Everybody wants to get something thrown out there. Uh, so we've added a couple of these out there in the literature, which have a lot of validity, even though we use veracity instead of validity. So here on the top, you have of the 5 V's of big data, and I've seen as many as like 11. It just gets silly after a while. But anyway, you've got volume, variety, and velocity that we've already talked about. But then, if you think about it, some other considerations of big data are veracity, and that's being able to trust the source and the accuracy. Um, the Is it backed up? You know what I mean? There's a lot of quite a few um, concerns, challenges when it comes to data veracity in big data. That can particularly be true in cybersecurity. You've got a huge amount of log file data uh, and packets and traffic to be analyzed. Um, and you don't always know that it came from where it came from. You don't always know that users are who they say they are and what they are. And there's just yeah, huge issue. And then within social media, can we really trust people are who they are? I think we've learned we cannot. And then assigning value to the data. You generally speaking, um, an enterprise, a significant sized enterprise, say a major hospital or maybe a business like I don't know, General Motors, that they can't uh, really store and process and love and nurture every piece of data. So most of their chief data officer um, level folks will have to assign a value to data. Um, like what's the value of a new sales lead? What's the value of old account data? What's the value of um, you know cash register data from 3 years ago? Maybe not valuable at all. Maybe you aggregate that, put it in a data warehouse, and you let it go. If it's just too much to store, not worth the cost of storage. Or sometimes data can be a liability that you, as an organization, you don't want to keep it around forever. Particularly if there's no business need for it, and there's no statutory um, demand for you to retain that data. If both of those are, are looked at and in your data management plan, the time has come to retire that data, delete it. You need to delete it. If you've got stuff that's old, it's subject to legal discovery, it's subject to audit, if it's on file, if you have it. And if you don't need it and you don't have to keep it, get rid of it is the usual uh, um, wisdom out there in records management is where I learned that my last 3 years in the military were as the command records manager at U.S. Central Command. And yeah, if you've got something in your files and a court order comes in to search your files and anything pops up, you then have to process it, redact it, prepare it for release, all of that kind of stuff. And if there was no reason, if it's just junk, it's just a liability. So, something to think about. So these next couple of graphics here, one is they're both a little old, but it just gives you an idea of what's going on here in the world of data. Um, internet searches, the amount of streaming data that's coming across the internet, wearable devices, IoT, how many pictures are being taken, and pictures are data. Um, have you ever downloaded Google Lens, Lens? Uh, my son texted me. I had a company I was working with that wanted to use image recognition. They wanted to snap a picture of a part coming into inventory and it just go boop into inventory. They didn't want to have to type in part numbers. They didn't want to have to scan anything with a scan gun. They just wanted to take a picture. And it's possible, but I couldn't find a an off the shelf implementation of exactly what they were talking about that integrated with their inventory system. So, but a great example of what we're talking about is called Google Lens, where it can take a picture. Try it, download it. You can take a picture of something. I took a picture of some very mundane things. One was a like a 1 foot 1/8 inch stereo cord. Like you'd hook your phone to your external speaker. One of those little 1 foot cords, and it recognized it and pulled up shopping links. That's really basically what it's there for now. The current implementation is it I want to buy this thing, but I don't know what this thing is called or where to shop for it. So I take a picture of it and boop, here you go. You can buy this thing. So yeah, the image recognition is there, whether it's facial or object. So all of these pictures being taken, it's data. It's data that can identify where things are and what else is around. You can guess the time of year. You know what I mean? There's just who were you with? There's it's data and it can be analyzed, and it might be just sitting now in some massive data center, but the future potential applications of that are gargantuan. So anyway, yeah, this is you can find this a day in data. You can find this out there on the internet. They haven't updated it since like 2015. I've been using this for too long, but I can't find a newer one. I can't find a better one. I tried again just this morning, but I did find a different one that even to me more clearly starts to look at the government data, which has huge public concerns for privacy and Big Brother and overreach but there's fantastic potential for good in analyzing all this big data, whether it's climate data coming from all of our sensors, or traffic data trying to make the roads more efficient. There's a whole circle of data sources, and it's starting from the inside moving out is time, and how things have grown, uh, and it is, I don't know, it's beyond exponential. Um, so anyway, yeah, I thought that was an interesting graphic. I'll post these slides. You'll see the file attached out there. Okay, so yeah, the growth of data in the 3Bs or the 5Bs or the 7Bs, however you look at it. That's what we're talking about. And then I wanted to go into a little bit about um, the data analytics life cycle, because this is part of it. You'll see this sort of these next two slides. You'll see this as a data science project, the life cycle of a data science project. This is also somewhat the way your dissertation research project will flow, with the exception that generally for your dissertation you were doing all the work. But in a traditional setting, um, that top bullet there, every data science project starts with a question. I think that's important to understand. I work more or less daily at the lower end of maybe the middle of data science and data analytics. Um, I work for a nonprofit. It's a 20-hour a week part-time effort. I work with a nonprofit that lines up training for people that are upskilling or reskilling, to get into IT from other fields that are not as employable as IT. And one of those, I work with companies that are growing their analytics efforts, or they have a mature analytics efforts. They just need to hire a new analyst. Um, and I teach an introductory data analysis course for people who are not analysts, to get them kind of up to speed on sources of data, data types, data wrangling with Excel, basic statistics, Python, all the way up from Hello World to Seaborn, Matplotlib, Pandas, that sort of stuff. A little bit of Power BI for data visualization, and data acquisition using SQL. And when I'm working with these analysts, uh, virtually always, we will find that their management just wants to know, what's the data say? What's the data telling us? Without, well, what do you want to know? That's the important thing to remember in data science is the question. The question determines everything, because depending on how you phrase your question, that's going to talk about what kind of data we need, the methodology or the model. Are we looking at something that's purely historical? Are we trying to do some sort of progression or prediction using a regression model? So how you phrase your question, um, is really important. So that's the first step of any data analytics life cycle. And you will notice in the content folder this week, that there is a research question section. And that is really important to understand as you move forward with your dissertation, because your dissertation will ask and answer one or a small handful of research questions. And that will determine everything. Your question determines everything, and we'll go into that a little bit more, I guess, as the semester progresses, and certainly as you progress in the program. The notion of developing, somebody on the faculty can ask you, what's your research question? And very often students will come back with well, I'm researching big data. That's not a research question. That's a topic area. Yeah, getting to know what a research question is essential at work or here in your PhD program. Next step, and this is one model, one little analytics life cycle I downloaded. I don't. It's. I thought it had good points. Um, and the next one was to make sure that you've got roles there. You've got folks in the organization that can support these different roles. Sometimes it's going to be the same person. Sometimes it'll be separate folks all among. So you've got the business user. This could be, say, we're doing something um, that's marketing, and we're going to predict the outcome of you know spending money or whatever on marketing. So in that case, a business user would be somebody who would use the results of this data science to shape a marketing campaign, say. Project sponsor is usually management or a senior person that can break down barriers and speed things up, help set priorities, because very often a data science project will span departments, and you need a poobah to kind of be your main sponsor. Project manager is literally like PMP, project management. Where you set up your tasks and allocate resources, and you've got your cost and schedule and project initiation, project completion, all that sort of stuff. Somebody needs to be managing the analytics as a project, and this is kind of assuming it's a standalone project. This isn't the monthly report. I mean, the monthly report comes out automatically, but the maintenance and improvement of the monthly report could definitely be something that is addressed like through this life cycle, and that could be your KPIs in your dashboard and your knowledge management system. Those sort of need to be constantly assessed and improved. BI analyst, business intelligence analyst, is generally speaking the person that does the visualization, which I mean, you got to know a little bit about data. You got to know, but and operations and what the key performance indicators are and what's important to measure. But they're generally speaking, they're the people that use the tool that puts it in front of leadership so that it can be used as intelligence, as decision quality display. Power BI and Tableau are huge. I got another organization that uses Domo. Google. You can do BI in like Python, Jupyter notebooks, that sort of thing. But I think traditionally the way we think about it, uh, Microsoft Power BI and Tableau, which I'm pretty sure was bought by Salesforce, um, fulfill that role. A DBA, database administrator, generally speaking, that they're the person that manages accounts and the storage area, optimizes queries, those sorts of things, sets up new schemas for you to put tables in, administering the database. You need somebody is going to need to be that, but increasingly I'm seeing DBA and data engineer uh, kind of overlapping a lot. Data engineer is what I'm seeing. The AWS and Microsoft and Google have certifications in this. Well, AWS doesn't have one that's named data engineer, but Microsoft has a Azure Data Engineer Associate certification, and Google has a Data Engineering Professional. And those are the guys that generally um, move data around and check for quality in support of an analytical effort. I've also seen the job title data warehouse developer in there, which is almost all data engineering. So, yeah, and but then you've got database developer, which is really somebody who looks at business needs and the way an application works, and make sure that the Oracle database behind the application supports what the users need out there through a mobile or a web or client server or whatever application. So you've got database developers too, but that's really more about like application development as opposed to analytics. And then finally, we've got our data scientist, and that's really more about the models, the the statistics that we're going to use, or the machine learning algorithm, and they're um, responsible for getting to know the data enough to know which, like, there are uh, k nearest neighbors and k means, and it's just, I'm not a statistician and I'm not a machine learning engineer. There are there's regression models, there's logistic regression, there's simple linear regression. There's so many ways for a computer, for software to look at data and do something with it, and that's what the data side is. It's really more about the how than the mechanics of the project, or putting it into action. The data scientist isn't really responsible for operationalizing the analysis. That's what the business user community does. So anyway, there's no bright line. I mean, there's a lot of overlap among these roles. So yeah, it starts with a question, but then we do discovery, where you go see what data exists. Sometimes you've got a gap. Um, you may find that you need to buy data from somewhere. The API, grabbing data off of an API isn't necessarily free. So there may be a cost involved. You may find that you've got to generate data, either start collecting it, modify an application to start collecting it. It may be survey data, that sort of thing, marketing data that you have to go purchase. Anyway, so yeah, discovery is just going and looking at, okay, well, we got this data analytics project we're doing. What's out there as far as um, data available, and maybe even tools. You may not have the tools that you need, and you may have to put in a request with IT to get TensorFlow installed or something like that, and it might take 3 months. So you find out all this stuff, and that's why you need a project manager um, in discovery. And then data prep, of course, is all the cleansing, where you cut stuff off of a column that you don't need because it's just some weird code, and you make sure your metadata is all useful, because column names matter when you're messing around with a bunch of columns. Um, make sure stuff gets in the right format. You could assign a data type. A lot of times, especially dates. Dates are really the most challenging of the basic data types to work with, because they very often get read in as text, and you want them to be treated as a date time. So you got to go in and make sure that the whatever software you're using is looking at things as if it's a string, it's a string. Maybe you might want a categorical data, because software tools like Excel or Python or whatever will treat a categorical variable differently than they will just a string, or a 0 and a 1 will look like an integer type, but it's not. It's a categorical true false. So anyway, data prep, yeah, that's a whole nother universe. I know at least one person is an ETL engineer, and they're all about data prep all day, every day. when you're doing ETL. But then model planning, this is where your data scientist kind of starts to get really involved here is what what are we going to feed this data into? And it may be a simple set of metrics, but it could be a machine learning algorithm. You might be doing a classifier that that's a fraud detection is a huge classifier, or the value of a sales lead, and which salesperson is going to get this lead because it's been classified as a high quality lead, those sorts of things. So there's the model could be any number of things, and then model building is actually putting it into software, and getting ready for this prepared data to be fed into it to generate results, which you then communicate the results. Very often, uh, I would say very often that's visualization, because data looks like just a bunch of text numbers on the screen, but you start showing things in relative size. You start showing trend lines going up or down. You start showing gaps in things, and the human mind um, uh, can perceive a lot more data in a picture than it can in like a spreadsheet full of numbers, and we all know that. So communicating results, but there's also a storytelling aspect to the data, where you sort of walk the audience through um, what's important, and you got to be careful, not to impose researcher bias into that storytelling. But yeah, you're definitely going to communicate the results, because if you get assigned an analytical uh, um, project and you don't get the results up in front of the C-level executive that needs to see it, it's like it never happened. And that's happened to me. I've had, and most of my experiences in government, military particularly, we've had somebody ask a question. Well, why do we do such and such? And how many times has that happened? And then, because we didn't use this analytics um, process, because we didn't have a sponsor, somebody that cared, it was just one of those things where you email it up to the boss, and it gets glanced at, and they've moved on, they don't care anymore. So yeah, if you don't communicate the results, it's as if the project never happened. And then step 6, hopefully, if this is a mature process, you'll operationalize the results, which means it'll affect decisions. This will now become this analysis that you did will either make a one-time decision supported by data. It'll support a one-time decision, or it will be incorporated into some operational system that looks at, maybe it could be real time, like when to let cashiers go from Walmart because activity has dropped, or when to let servers go at a restaurant because activity has dropped, or when to uh, increase security because chatter on social media has increased, or whatever the case may be. Or it could just be something that gets added to your monthly or quarterly report. So, but hopefully the results of this analysis project get operationalized. And then, so that's just kind of wanted to go back and talk basically about data science, data analytics. This week we have two particular applications. Healthcare analytics is in our discussion board, and we already talked a little bit about that. The volume of things coming into the healthcare domain, medical coding and billing and insurance claims, and study data and lab data on individual people and diagnostic imagery. It's just huge. EHR is like the only hope, but we don't really necessarily have. We're working towards it. Um, Hopefully, you guys can, if you're in this world, you can weave that into your discussion post. Um, where are we at with the standardization of EHRs? Almost like the internet consortium that standardizes what TCP/IP is and what those protocols are and how they're going to interoperate. Well, we don't have something that's as rigid for electronic healthcare records and how we're going to store healthcare data. But they're working towards it. So maybe some of you guys are working in that domain. So that's the first domain is healthcare analytics, and there's some reading materials out there, and it's kind of generic. You'll see when we talk about the discussion post. Um, we don't we're not becoming subject matter experts in it. We're talking about how to research it. Always remember that the your any subject you study in any of these PhD ID classes, it's just to learn just enough so that you can read journal articles in that domain and understand what they were studying and why, and the methodology and the findings. It's not so that you can put any of this into practice. Not That's not what this coursework is for, at least in my experience. So there you go. So healthcare analytics, and we'll talk about the discussion post here in just a minute. And then you've got, like I said, advanced manufacturing, from product development, research and development. You got people analyzing marketing needs and trends, that feed the need into the manufacturing process. And then when you're actually manufacturing things, you've got that whole life cycle of, you know, parts and assemblies and raw materials and suppliers that you have relationships with, and reorder points and demand levels and locations. You've got, little robots grabbing stuff off of shelves and taking it to the manufacturing floor. Then you've got sensors that are measuring and counting assemblies as they go through the manufacturing process. You've got test and quality data on a certain amount of the products as they go through the manufacturing process, that's got to be stored and fed back into the manufacturing process. Then you've got on the other side, you've got finished inventory and sales and demand and reports from the field, diagnostics from the field. So there's just, huge amount of information. And we'll go over the paper's instructions here in just a minute. So that's your other domain that we've crammed into week 2. So your week 2 discussion assignment. Think about healthcare analytics and in the healthcare industry, and then you're supposed to pick one of these 4 categories of challenges. Okay. So you're identifying the challenges associated with data gathering in a healthcare scenario. Okay. So data gathering is going to be just what we talked about. And what challenges are there? There's good, go on Google Scholar, read up on it. When you're gathering healthcare data, you've got privacy issues, you've got compatibility issues, availability. Not every patient population has access to the gee whiz electronic health records. So gathering the data has its own set of challenges. And then once you do gather it, you've got storage and integration. And again, uh, anytime you're talking healthcare, you're going to be talking about privacy, pretty much. Storage, it can be uh, a big data problem. It can be something that needs to be stored in something like a Hadoop or Spark cluster more than on a desktop computer, say, or something like that. You've got challenges integrating the data. Again, different formats. Um, so you don't want to average you know data from one place that's in metric and data that's another place that's in imperial. So and challenges associated with data analysis could be the availability of tools, could be the availability of these are challenges associated with data analysis, could be kind of like we talked about with the 3F method, could be availability of expertise, established models, sufficient amount of data. You're always hearing in the COVID world, you're always hearing, well, we need more data on that. We need more data on that because if you've had statistics, the larger your sample from a population, the more confidence, blah blah blah. So knowledge discovery and information interpretation. I don't know. I don't know that I've ever seen anybody choose one of those. So extra credit if you pick knowledge discovery and information interpretation. And you absolutely, I say, feel free. You got to get out there, guys. You got to get into the library, into Google Scholar, and just dig into these topics. There's just no way I can cover anything of substance in an hour. Okay, so in the week 2 discussion. Okay, now I chastised some of you this week in week 1, and please, if you have any doubts as to what I'm talking about, go back and look at my interaction in the discussion board in week 1. I'm still seeing it's a great post, so full of information. I just want to add a few points. And then a few people even put like the 3F method has 3 stages. We know that. We know that. Don't put simplistic stuff like you're adding a few points. Okay? Think about it. Don't insult your fellow students with simplistic statements of the obvious. Okay, this is a PhD course. I think everyone that cares saw some great examples this week of real discussion, of true, authentic, collegial discussion about these topics. And then you saw some people posting stuff that had nothing to do with the topic. And that's what I'm saying. You shouldn't be tolerating that from each other. If somebody replies to you and you have no idea what they're talking about because they have no idea what they're talking about, you should say something. And you don't have to be, you know, you don't have to call them names, but you should say, I don't understand what you're talking about. Can you rephrase your statement? Because it doesn't have anything to do with this week's discussion. You should feel confident in that. Um, and you should feel obligated to post quality work. This is a PhD course. It doesn't get any better than this. Okay? So if you haven't stepped it up, step it up. If you're one of the people who are stepping it up, I really appreciate it. And I love reading your posts. Love it. So hopefully we can move beyond um, the ridiculous add a few points nonsense and actually really truly authentically discuss the topics. Any questions on that? Please feel free to email me. All right. I talked about it a lot in my week 1 lecture. I'm a bit ashamed that I still have to talk about this. Okay, so you've got that discussion and a research paper. So your week 2 research paper makes that mental jump back over to manufacturing, right? Data-driven manufacturing. Um, So this paper, 4 to 6 pages. I'll take 3 good pages. The main thing are to put 2 sections: the benefits and challenges. So I would like to see a header um, where you separate the benefits and the challenges of big data analytics in the field of advanced manufacturing. And there is no end of material out there for you to use in your papers. So, uh, yeah, converse, don't lecture. That was on the last slide. Okay, so yeah, research paper, APA format. In fact, I'll post a sample APA paper. Um, I still see, even at the end of 16-week semesters, I see people that are not indenting paragraphs, um, that are using a colon at the end of a section heading, which is not APA format. And it makes me wonder which paper you rip that off of, because it's not a template APA paper. It must have been something from Course Hero or something. So hopefully I won't see that. Use the template paper that I attached to this assignment, please. Okay. Yeah. Challenges and benefits in the field of advanced manufacturing. Okay, so it should be really, really easy for me to see in your discussions and your research paper what it is you're talking about. And if you have any questions, please email me. Okay. In conclusion, yeah, big data is exploding in everything. It's just in everything. And the people, the tools, we're getting blown backwards, I think. Every once in a while, we make progress with a new tool or a new technique or whatever. But organizations are overwhelmed. So this is a growth industry. And again, in class, please don't lecture your classmates. And don't, if somebody tells you something that you already posted, uh, politely call them out. Okay. Please politely call them out. I would really, really like to get over this component of the University of the Cumberlands. These discussion posts. I get better discussion posts from another major online university at the undergrad level. So step it up, be real, be authentic, actually engage in conversation. Okay, don't just add a few points. Even if you don't say, I'd like to add a few points, and all you do is post something that everybody knows, like we saw with the 3F method. Everybody knows what the 3F method is. Nobody needs to see a paragraph of that. So yeah, it's the statement of the obvious. It's contributing nothing that it's frustrating me incredibly in class discussion. I'd like to see that come to an abrupt end, please. Okay. And as always, questions, concerns, there's a lot of material crammed into each week. So if you run into anything confusing on what I'm looking for, let me know. The main thing is, as I said in week 1 in my academic writing for systems engineers, is to read the instructions and stick to the instructions. I will never look for something that isn't right here in the instructions. So if you follow it as closely as you can, the better off you'll be. But if you have any questions or concerns, please email me, and I'll see everybody in class discussion.